Hello everyone. So this is the continuation video of design and analysis of algorithms, and this video especially talks about performance analysis. Okay, now let's start the session. Usually if I'm given with one problem, now this problem will have many solutions, right? This problem will have many solutions. Now for all solutions we can write step by step process, that is of algorithm. So this is one solution, so one, two solution, three solution. For all these three you can write step by step process. All these three are different solutions to fulfill this problem. Okay, how to tell one algorithm is efficient? I can tell all these are three solutions for this problem. So when I have all these three, which algorithm I should pick in what circumstances, or else what is the efficiency of an algorithm, how to know it? That's what the study of performance analysis. So performance analysis is if you can write solutions for one problem, all the three algorithms we will be going to calculate performance analysis. What is performance analysis? Let's think about the example. Okay, now the example is if you wanted to reach, so most of the times we will be given with some solving of puzzles in daily newspaper, right? Now assume that here it is a bread, and here it is one bird, something like. So I'm not good painter to draw it, but for the example purpose I'm making you to understand this. Now, there are many ways to reach. The bird can go in many ways, right? There are many ways to go to take this bread. Okay, now this bird can go to take this bread in many ways, right? So from this way it can go, from this way also it can go, or else from this path also, or else from this path. It is having more number of paths, but which way it will go? Or else, of course, you may ask a question, how bird can choose all this, right? uh, Take the example of that you are here and you wanted to go somewhere, then how we will think that the path which takes us very less time to reach this place, and the distance, we will always think about the distance and the time. So these are what the major two things which we will choose in order to reach our destinations. In the same manner, when you have three solutions, you will be also thinking about two major things. The two major things are, the one is space complexity and the other one is time complexity. Let's see about what is space complexity. The amount of computer memory space which is required to execute an algorithm. This is what space complexity. So when you are writing an algorithm, we will be writing step by step. So in one step there will be something to store into our computer memory, right? So the amount of computer memory space which is allocated or which is required to execute an algorithm. Now let's see. To write an algorithm, generally we require space. For what we require space? Instruction space, data space, environment space. Now what is instruction space? How many executable instructions you have. You can take the example of previous one. Consider this example. These two solutions or these two algorithms are to solve single problem. That the single problem is add of two numbers or addition of two numbers. This is the task. So to fulfill this task, I am writing two solutions. This is one solution and this is the other one. Now what is space complexity that we were seeing, right? So to write algorithm, generally we require space for instruction space. What is instruction space? how many executable instructions, that is instruction space. So how many executable instructions are here? 1 2 3, and here 1 2. And so no comment line will be considered as an executable instruction. Okay. Let us suppose I wrote here 3 lines of code. Now I wanted to add one more line here which is non-executable statement, and it is comment line. So in the comment line I'll write read the above values or perform the below function, print the result. So I'll write 3 more comment lines to describe what the first one, what the second one, what the third one. Though then the count of lines will get increased, the count of lines will become of 6. Still the lines are 6, but still we will take into 3 as the consideration, because the main agenda is instruction space always will take executable instructions. So as we know, comment lines are not executable instructions. Those will not comes under this count. Okay. So if you have 3 lines of code which is executable instruction, you have to tell 3 instructions are having. So instruction space of this algorithm is 3. Okay. Instruction space of this algorithm is 3. If I have 3 more lines of comment lines, also it is 3. Okay. Now look at the next. Data space required to store variables and values. So now look at data space. What variables we do have? A is one variable, right? A is one variable, B is second variable, C is third variable. So what is data space of this program or this algorithm? What is data space? Three variables, right? So now as soon as you encountered a variable in the program, computer memory will get existed with some memory location. Now it is a, some address of 100 it will get exist. Now whatever value you will supply through scanf statement, that the value will get placed here. Okay. So though you have value or not, it doesn't matter. Only the matter is you have to give an variable with the data type. So when compiler find a variable name in the program, it doesn't require any value in the case of space complexity. Space complexity always looks into the variable memory. That's it. Whether what value it is having, it doesn't care about it. Okay. Space complexity is what? The amount of space which is required to execute the algorithm or the program. Fine. Now, so what is data space of this algorithm? 3, because A is 1, B is 2, C is 3. So total we do have 3 variables, and data space of that algorithm is 3. Now, environment space. To store the environment information needed to resume the suspended function. The mean of this is we will be taking some environments to write the programs, right? So that environment, it will be running all the functions what are required to execute this particular block of code. That is what environmental space. Now, space complexity can be calculated based on constant values and linear program. So it is basically calculated in 2 ways: constant time space complexity, linear space complexity. Now look at this. Algorithm requires fixed amount of space for all input values is called as constant space complexity. It's constant, fixed amount space. Now you look at this example. I believe that you can understand something from this example. So here is a function, or here is a small algorithm to find out square of a number. So what is the space complexity of this? How many variables I do have? Only one variable, right? So if you come here, now let us talk that I have a variable, now which my variable is a. So variable is what we were defined. So it is a specific memory location. So I am taking some specific memory location. So now a is, let us suppose a value is 2. Okay, at this statement a value is 2. If you come down to the next line, it is having written a into a. So this value 2, as I given a is equal to 2 into 2 is equal to 4. So that 4 will get updated into a. So what is this telling? This is fixed amount space or constant amount space. You have constant variables. That is of one variable and that is constant variable. So when you have constant variable in the algorithm, that is what fixed amount space. Let's say linear space. Linear space is something that we will be having loop. So here it is not having fixed, it will be varies till n value as long as n value get modifies. So for suppose if I give scanf of n value, now this n value, I am going to read this n value. If my n value is 1, so it is not constant because I am depending on this n, not 1. If my n value can be of 1, n value can be of 10, n value can be of 100. Now this is what? It is not fixed. So but in the case of last, it is fixed amount of space. So you have only single variable, so you will allocate memory for this variable itself. So when you come to here, you don't know how many values you are going to place. For every execution, you can change your n value. Fine. I less than n. If n value is 1, so now what happens? It will be having some space. It has to store only one value of it. If n value is 5, in all iterations of 5 values will get updated. If n value is 10, for all values of I, it will be get updated. Right? Did you understand? Linear space complexity is, this is something like of n. Constant space complexity is, this is something like of 1 constant. Now for the clarity purpose I am giving this chart. So when the size is n, it takes one word. So most of the times we'll be having enter n size, right? So that n is one word. So when you have array a values, the memory space which is required to store this a is n. If you give here 1, so don't give I for 1, give for n. Okay, now I'll clarify this one. So usually we will write a of I, right? What do you mean by a of I? Array elements with the indexes. If you are taking I as one variable, I is equal to 1, then a will be what? For each time I will get modified, right? So you have to take n. If you take I as n, array you should take as 1. Now look at this. Array a values. So as I have n values, I am taking n words. So this is what the storage. So if I have one variable in my program, I need one word of space. If I had one variable in my program, I need one word of space. Now sum is also one variable in the program, that also takes one word. So whereas array is having not only one variable, it highly depends upon this n. So that's what it takes n words. So this is what the space complexity. Now look at this example. Int sum int a. So that means what? It takes n. Int n means what? One variable, 1. Sum 1, I 1. Now 1 plus 1 plus 2 plus 3, 3 plus n. This is what the space complexity. In the space complexity, we should always think about the variables. For how many variables we will be going to store into your computer memory. So instruction space is what? What is the instruction space? This line will get executed for single time, right? And this line will get executed for single time, and this line will get executed for n times. Okay? So 1 plus 1, 2, 2 plus n. And next, this line also will take single line. So that means 3. So 3 plus n, return sum 4. If you add even this open braces, 1, 2, 3, 4, 5, 6, 7, then it becomes 7 plus n, the space complexity. Instruction space complexity. The data space complexity is what? Number of variables. So number of variables of what? N, array, I, sum. 1, n, 1, 1 means 3 plus n is what? Data space complexity. Instruction space complexity is what? 7 plus n. 6 plus n. Because we'll leave this for loop, it will be of n. One line of instruction. So it take one word of space. 2, 3. And this is what? N. 3, 4, 5, 6. Total 6 plus n. What is this? instruction space complexity. Instruction space complexity of this algorithm is 6 plus n. Data space complexity of this algorithm is 3 plus n. Okay, did you understand? Now look at the time complexity. Better we'll take one more video of time complexity. So I'll stop here. The next video will continue about time complexity. Okay, thank you all.